Welcome back to Math with Pi, and we're going to be looking at problem number 15 from the AMC 10B. This is from 2015. The town of Hamlet has 3 people for each horse, 4 sheep for each cow, and 3 ducks for each person. Which of the following could not possibly be the total number of people, horses, sheep, cows, and ducks in Hamlet? So I'm noticing something interesting here, and that's that this problem is asking which of the following cannot be something. And so I'm going to say, oh, look, that means that my answer choices are actually important. And that's correct, because in this case, we need to use the answer choices, and it's not independent. So we need to figure out which of these do not make sense. So I'm going to go back and read through this problem, and I'm going to say there's 3 people for each horse. So that means there's going to be 3 people for 1 horse. And then I'm going to say 4 sheep for a cow. And 3 ducks per person. Which of the following could not be the number? Okay, so if there's 3 ducks per person and 3 people for horse, I can substitute P equals 3D, and I'll say there's 3 times 3D per horse. That's 9 ducks per horse. So it's going to be easier to maybe write things in terms of ducks because it's more widely applicable. Otherwise, I would say something like a horse is 1/3 of a person, and that's just weird. We don't want to get into fractions here. So I'm going to add these up, and I'm going to say I have 9 ducks per horse. I have 3 ducks per person. And I have 4 sheep per cow. So now I need to add the number of ducks, the number of horses, the number of sheep, the number of cows, and the number of people. But now I'm just going to plug in, so ducks remains ducks. Each horse becomes 9 ducks. Each sheep just stays that way. Each cow becomes 4 sheep, and each person is equal to 3 ducks. And all I'm doing is making sure I have an equation with only 2 variables instead of with all these 1, 2, 3, 4, 5 variables. So now I've got D plus 9D plus S plus 4S plus 3D equals some number. So let me set this up. Let me group some like terms. I've got 13D plus 5S equals, or rather in this case, what can it not equal? So when I look through the options, now I'm going to see which of these make sense and which of them don't. And maybe at the beginning, I'm going to have to walk through a little bit slowly to see if they really make sense or not. So I've got 41. And I'm going to say, can I write that as the sum of a multiple of 13 and a multiple of 5? So multiples of 13 leading up to 41 are going to be 13, 26, and 39. And when I have 13, how much am I going to add to 4? Actually, let's work backward. When I have 39, I'm going to add 2. When I have 26, I'm going to do 41 minus 26, which is 15. And hey, I don't even really have to go further because I do see this can be written as the sum of a multiple of 13 and a multiple of 5. So 41's off my list. Let me next look at 47. So I have these multiples, 13, 26, 39. When I take 13, I know 47 can be written as 13 plus 34. 47 can also be written as 26 plus 21. And it can be written as 39 plus 8. But the next multiple of 13 is going to exceed 47. It's going to be 52. And so I really can't write 47 as a multiple of 13, as some multiple of 13 and 5. So 47 right here is my answer because it cannot possibly be the total number. Now, if I had started with maybe 66 or another number, then I'd probably still work my way here until I noticed that there is a number that I cannot write in that form. This problem required you to be able to see how to group these so that we got an equation with only two variables. And then it needed you to be able to notice that we need a sum of the multiples of 13 and 5. So it's just looking for patterns and some trial and error with this one because you're considering answer choices. Thank you all so much for watching, and good luck on the upcoming AMC 10 and 12.